Good afternoon, guys. Mr. Moe here with Moe's Notes on relations and functions. Today, we need to understand relations and functions and how they relate to algebra. We need functions to allow us to name the whole process of evaluating a particular expression. This allows students to compare, discuss properties, and allow operations on functions to create new functions. The vocabulary for this lesson is shown and used throughout the lesson, future lessons, quizzes, tests, etc. I would suggest that you pause the video and write these down. We'll talk about these further tomorrow. Just imagine you have a function machine. This machine processes functions. And you can see here, there's an input and an output on the machine. And you have an equation that's being operated upon right here, and in this case it's a function, where the original equation was y equals x plus 9. Making it a function, it's the f of x, and that's the way that is said. It's not fx, it's the f of x is equal to x plus 9. So if you have an input of 3, then the f of 3 is 3 plus 9, or 12, and that would be the output. To be a function, if you put another 3 in, you can't get anything but 12 out, or it wouldn't be a function. Relations compare x and y values, and they can not only show in behavior. That's the end of the graph. See right there the arrows, that's in behavior. Or they can show maximums or minimums. They can show domain. They can show range. And turning points. Turning points would be the maximums and minimums. Functions are relations where every input, you may have only a single output. The relation between the variables x and y, you're very familiar with, the xy coordinates, can determine whether you have a function. While there are multiple representations of functions, check the tables, x coordinates, to see if they have more than one value of y. And if the table or coordinates have all different values of x, then it's a function. Often the easiest method to identify functions is graphically, using the old vertical line test. Speaking of graphs, if you have a series of graphs, you can draw vertical lines on each of them, and that's going to look just like these. Where you notice the smiley faces, those are functions, and sad faces are not. You notice that these vertical lines only pass through one point on the graph. While these vertical lines on the second graph, the oval, you see that vertical line right there passes through the point here and here, then that would mean that it's not a function. Passes through multiple points there, not a function. Passes through more than one point here, not a function. But the rest of these, they're functions. So, if you're given coordinates or tables or mappings, if x has a single value of y, the relation is not a function. Notice x here, a, b, and c. If those three are different, then you have a function. Same with the mapping right below that. A, b, and c gives you 4 and 0. A, b, and c, the values of x are different, the inputs are different, and outputs, well, outputs, you don't care if they're the same or different. It's the inputs that matter, that tell you if it's a function. Because you notice over here, there's 4, 9, 4, negative 7. Both of those are not functions because their outputs, respectively, are 9 and negative 7. Same with that mapping. So the next thing we want to do is be able to evaluate functions. functions, and we're going to do this in 4 different steps. 1, if you're given the function, and again, this is the f of x is equal to 3x minus 1. Originally, it was an equation, y equals 3x minus 1, but you want to deal with it as if it was a function. So you're asked to find the f of 2 given the f of x equals 3x minus 1. It's changed from an equation to an expression now. So the right-hand side, you're going to substitute 2 in for x. You'll notice that the f of 2 equals 3 times 2 minus 1. So all you've done is substituted 2 in for x. Make sure when you substitute that you do it in parentheses. It's important that you show this work this way. Also, you notice that we're working down the pages, just like you do with equations. Well, that's the normal way to do algebra, is to work down the page. You don't do it horizontally. So once you substitute that value of 2 in, then all you do is simplify the right-hand side of the function. You simplify the expression. So basically the functions, you take them from equations to expressions. And you notice here, if you're writing it down like you're supposed to, you write the original, you substitute the values, you simplify the expression, and if you have the f of 2 and it gives you an output of 5, 2 is the input, 5 is the output, 2 is x, 5 is y. Functions and relations. All right, well, we're almost finished with today. Let's see, for identifying functions, look at your domain values and determine if they're repeat. If x is your input and it gives multiple values of y, then it is not a function. You may draw a quick graphical representation and use or visualize the vertical line test. And finally, to evaluate functions, you just have to substitute the input, the x-coordinate, into the function and simplify only the right-hand side of the function to find the y-coordinate. Remember, it goes from an equation to a function, and you simplify expressions. Have a good night. See you tomorrow.